All right, this is week 4, Math 208, section 4.1. All right, so the directions say a solution to a system of two equations in two variables is, and those are our three choices: ordered pair, x-coordinate of the y-intercept, or y-coordinate of the intercept. Okay, so what does that mean? So a solution to a system of two equations in two variables. Okay, so two equations in two variables. What that means is you've got two lines. Let's say one line says y is equal to 3x minus 4, and then the other line is, let's say, y is equal to 2/5 x plus 1. Okay, I just totally made those up. It doesn't really matter what they are. The point is, you know that both of these are lines, okay? Now, these lines, there's a couple of things that are going to happen, but one of the things that is very likely to happen is those two lines are going to intersect. So let's say one line goes like this, and let's say another line goes like this. And so the intersection, it happens to be right there. Okay, so now that place right there, that is an ordered pair. That's some sort of ordered pair. X comma y. That's an ordered pair right there. So when you have two equations, meaning two lines, the solution, so here's the key thing. The solution is where those two lines cross. And that where those two lines cross, wherever it is, that's the ordered pair. Now the deal is those two lines can cross in any way. All right, so I happen to make them look like they're going to cross right there on an axis. See that right there? But they don't have to. Perhaps one of the lines could look, like this. And then the other line could look like, I don't know, this. All right, and so now they're crossing right here. And so that little piece, that place that they intersect, that is called the solution, and it is always a point, an ordered pair, x comma y. But here's the cool thing. Those two lines that we just talked about on the previous slide, they don't always have to intersect. So that's the cool thing. It's possible that you might have, let's see, a line that, well, you might have two lines. Let's say one line going like this, and then another line going like this. So how many solutions do they have? They have one solution right there. There is your one solution. So you might have one solution, and let's keep going back, or perhaps you might have one line going like this, but your other line going like this. In which case, how many solutions do they have? They have no solutions because these two lines are parallel, so they're never going to meet. So you have a couple of options. You have one solution where they cross. You have no solutions because they're parallel. Now here's the cool thing. Or you might have an infinite number of solutions because maybe one line looks like this, and then the other line is smack dab on top of it. So now you have an infinite number of solutions. So getting back to our options, when you have two lines, you either have one intersection, one solution right there. You have no solutions because they're parallel, so they're never going to cross. Or maybe you're going to have an infinite number of solutions because they're identical. Those two lines are identical. They're on top of each other. So that's why when you are solving a system of equations, meaning when you are graphing two lines and you're trying to figure out where or if they cross, you have three possibilities. And the three possibilities are no solutions, meaning they're not going to cross at all. One solution, meaning, yep, they cross right there. Or infinite number of solutions because they're the same line. So your answer is this one, that third option there. Now here it says, if a system of linear equations has no solutions, then what? Well, first off, let's just remind ourselves. So if a system of linear equations, meaning you have two lines, all right? And, let's make one line go this direction, and let's make the other line go in the exact same direction, totally parallel, all right? And the reason I'm doing that is because the directions say a system of linear equations has no solutions. So when it has no solutions, that means those two lines must be parallel. They cannot be crossing like that because their solution would be right there, a point. And they cannot be identical. They can't be on top of each other because then they would have an infinite number of solutions. So if they have no solutions, that means they're parallel, like this. And we call that inconsistent. All right, so the directions say, if a system of linear equations has infinitely many solutions, and the little lines are in the way, then the equations are, and we have two choices, dependent or independent. So if they have infinitely number of solutions, so what does that mean? Well, that means your two lines, you have two lines, and let's say one line is going like this, and what is the other line doing in order to have an infinite number of solutions? Is it going like this? No, because then it would have one solution right there. Is it going like this? No, that would have no solutions because they never cross. So what does it mean to have an infinite number of solutions? It means those two lines are on top of each other. They are identical. And when you have an infinite number of solutions, those lines are identical, they're called dependent because they're like on top of each other. They're dependent on each other. And the last thing, so let's say you've got that graph, all right, and there's our graph. And keeping in mind, there's your x-axis and y-axis. That should be second nature by now. And let's say we've got this graph, and we have two lines, okay? And, let's do one black right there. And, let's do the other one in blue. So the other one, we're going to go this way, like that. All right, so there's our two lines, okay? And of course, we have a solution. Boom, right there. Now, the question is asking us, if a graphical method and a numerical method are used to solve the same system of equations. Now, what the heck does that mean, to solve the same system of equations? Basically, that means solve the same system of equations means you need to look for the location where those two lines cross. We got a couple of options. You're going to learn them. You don't know them yet as of this video, but we got one option called the graphing method, meaning graph it and take a look at where they cross. Another method is called the numerical method, which is a table of values. You make a series of tables and you look to see where the two tables match. So you got a variety of methods, but the idea is, regardless of your method, you should always have the same solution. If these two lines match and they meet right there as your solution, your ordered pair, x, y, that means they're going to meet right there no matter what method you use to figure that out. And that wraps up this video.